Hey guys, in this video I'm going to talk to you about how to factor out a GCF. I'm going to talk about the factor tree method we've been working on to find GCFs, which arguably I think is a little bit slower than the method I prefer to use. We'll talk about that method on another day here. But this video will all be about factoring numbers out of parentheses. Now, what is factoring? So factoring is the idea that, back in the day when you did the distributive property, you would take some number on the outside of parentheses and multiply it into each thing in the parentheses. So in this case, if I took the 3 and multiplied it into both, I'd get 3x plus 6. I sort of said it was like if you have chips that you're at a party and you want to pass out chips to everybody at the party, you need to make sure everybody gets the chips. And that's what we did here with this problem. Now, the goal here with factoring, though, is going to be to try to undo this process, to try to see, like, how could I get from this step and revert back to this step over here. And we'll talk about how to do that with these 3 examples over here. Again, I won't get into variables with this today. I'm just going to look at, for this first part, factoring numbers out. So there is a faster way to do this, but for now, just bear with me with this method. If you know the other method, you're welcome to try the other one. So we've got 8x plus 6. We'll start here. And I'm going to break this apart using factor trees like we have been. So I'm going to take 8, and I'm going to split 8 up into 4 times 2. And then we'll split up the 4 into 2 times 2. So that gives us 2 times 2 times 2, which is the first term. And then we just need to tack an x on here because it's 8x. Now we're going to do the same thing with 6. We'll try to split up 6 into 3 and 2. That's about as far as we can go. So we'll put a plus sign in the middle with a 3 times 2. And now notice here we've got 2 terms. We've got 2 times 2 times 2 times x, and we've got 3 times 2. Now, again, earlier I said it's kind of like passing out chips at the party. Factoring is like the opposite. So it's almost like you passed out chips earlier and now you're throwing a temper tantrum because somebody broke your mom's vase at the party or something. So you're going to take all the chips back from everybody. As much stuff as they all have in common, you're going to try to steal back, and then you're going to sulk in the corner outside the party. So if you look, we got 2 times 2 times x and 3 times 2. What these 2 terms here have in common is a 2. That would be the greatest common factor of these 2 terms. So what we're going to do is take the 2 away from everybody. That's going to the outside. And then what's left on the inside? Well, we've got a 2 times 2 times x, which gives us a 4x. And then we've got a plus 3 here left over on the next term. The 2 is taken away. And an easy way to check your answer is to distribute this. So this is our answer right here. But if we distribute this back in, we see we get 8x plus 6. Oh yeah, that checks out. That is the answer we started with. You have to make sure you take out as much as you can. You don't just want to take out any common factor. You always want to take away as much as you can. So that's another little stipulation there. Okay, so let's look at the next one. We've got 18x plus 27. And we're going to start by looking for common factors by splitting this thing up. So we'll start by looking at 18, and if we split apart 18, that's going to split apart into 9 times 2. Could also do 6 times 3, doesn't really matter. And we'll split apart 9 into 3 times 3. Now, so that will give us for this first one, 3 times 2, and then we'll put our times x here because that had an x on it as well. For 27, if we split this one up, we're going to end up with 9 times 3. And if we split up 9, that'll be another 3 times 3. So we should get 3 times 3 times 3 should be our expression for 27. That should be our prime factorization there. Now, if we look carefully here, and we look for our things in common, I actually see that they both have not just 1 3 in common, but actually 2 3s in common on this one. So you could put a 3 times 3 on the outside, but we know what 3 times 3 is. 3 times 3 is just 9, so that means the biggest number that actually goes into both of these is 9. So the 9 is going to be what I'm taking out of here. And then on the inside, let's check out what's left. So we've got a 2x on that first term, plus we've got a 3 here on the next term. So that should be 2x plus 3 on the inside. And I'll leave it to you guys to double check that that works. You can distribute that 9 in and check it. But we're going to move on to the next one. One thing to notice is we have 2 terms on each of these here. So I'm seeing that I've got 2 terms on each of these here. So that's just something to keep in mind. If I had 3 terms, if I had to split up 3 things and see what they all have in common, That would be obviously another type of problem as well that we could do. But then it should have 3 terms on the inside. Okay, we got one more here, so let's split up 25y squared plus 5. And I'm going to start up by splitting up 25 into 5 times 5. And 5 I can't really split up, so I'm just going to bring that down. That's just going to be a 5. So let's write out what we have here. We've got 5 times 5. Now, I could write this as y squared, but in the next video when we work with variables, we're actually going to want to write this as y times y. So remember, if it was y squared, that means there's 2 y's multiplied together. So that's our first term. We'll put a plus 5 here. And now what we're going to do is, again, look what they have in common. So I see they both have a 5 in common, but I don't really see anything else. So let's bring the 5 to the outside. And here's where people make a mistake. So on a problem like this, they'll see that this should be 5 times y, which is 5y squared. But the mistake they make is they don't put anything in here to hold the place of this. We said earlier that if you have 2 terms at the beginning, 1, 2, we should have 1, 2 terms here at the end. So to figure out, if you ever circle all the parts of a certain term, we always need a little 1 here to hold the place of that, because we could have written this as having like an invisible 5 times 1 here when we took the 5 out. So don't ever, if you have 2 terms at the beginning and you circle all of one term, don't forget to include it in there. You need an invisible 1. And then if we check that, if we multiply that in, we should see we'd end up with 25y squared plus 5. So again, this video just dealt with trying to factor numbers out of parentheses. In the next video, we're going to look at how to factor variables out using the factor tree method. And then next time after that, we'll look at maybe a faster way to factor these things, with numbers, variables, and all that good stuff.